For activity 9.9, classification of triangles, we will need to go and look up the definitions for the 6 types of triangles in our e-text. So the first thing I am going to do is show you where to find your e-text and where to find the triangles. In My Left Math, on the left-hand side, you will see the e-text. So you will go ahead and open your e-text. And I can go to a specific page, and I want to go to page 558. We can also go to table of contents, find chapter 9, and scroll through the sections. Okay, so the section triangles and quadrilaterals is what we need to complete both 9.9 and 9.10. You will see a table, table 8, that has the definitions on the left-hand side of all the different triangles. So the first thing you need to do is go ahead and copy down those definitions onto your handout. After you have completed your definitions, we're going to go to number 2. We want to answer yes or no to each and draw a picture to justify your answer. For example, can a right triangle be a scaling triangle? Can you have a triangle with 3 different sides, so non-congruent sides, and a 90-degree angle? I think we can do that because I can draw, let's see, the 3, 4 to 5, 3, 4, 5. That is a right triangle that is scaling because it has all different sides. So you want to continue doing this for every single question for number 2. Answer yes or no, draw a picture of it. For number 3, we're going to use Venn diagrams to classify our triangles. And there are 3 scenarios possible. Disjoint sets means these definitions have nothing in common. One triangle cannot be the other. Intersecting sets would be the example we just had. You can have a right scaling triangle, but you definitely have triangles that are scaling and not right, and you definitely can have a right triangle that has a 90-degree angle, but that's not scaling. That would be intersecting. Subset would be all blank triangles fit the definition of the outer Venn diagram. The relationship between isosceles triangles and scaling triangles. Well, an isosceles triangle needs at least 2 congruent sides. Scaling triangles can have no sides congruent. That would therefore be disjoint. So I can make isosceles one of them, and scaling another. So an isosceles triangle has 2 or more equal sides. When we mark our triangles, we put little slashes through the sides to mark which sides are equal. So if I do this for scaling, 1, 2, and 3, that would be a scaling triangle. It cannot be isosceles and scaling at the same time. The relationship between isosceles triangles and equilateral triangles. Because our definition says that an isosceles triangle has at least 2 congruent sides and equilateral triangles have 3. That means that all your equilateral triangles are also isosceles. So that would then be a subset. So isosceles on the outside, equilateral on the inside. So that is a triangle with all equal sides, which has at least two equal sides, but we can have an isosceles triangle that has exactly two equal sides. Okay, isosceles triangle and a right triangle. That is going to be our example of intersecting. We can have an isosceles right triangle. In a right triangle, the hypotenuse, which is opposite of the 90-degree angle, has to be the longest side. We can have a right triangle that is scalene, which is what we just saw, the 3, 4, 5, that would be scalene. And of course, we can have isosceles triangles that don't have right angles. And now you have an example of each of the three different scenarios. So go ahead and finish 9.9.